Have you ever just looked at your car, or your smartphone, or even just a coffee maker, and really wondered, how did this actually get made? We are absolutely surrounded by these incredibly complex things, but how do they go from just an idea in someone's head to an actual object we can hold? Well, the answer is a total revolution in design, and it all starts with a digital blueprint.
That's the big question, right? How does that spark of imagination become a real, physical thing you can buy in a store? The whole journey has been completely transformed, and the secret really lies in creating a perfect digital version of almost everything long before a single piece of metal is ever cut.
Just look at this. This is a perfect example. It's a symphony of thousands of tiny, intricate parts, all having to fit and work together perfectly. And here's the amazing part. Every single one of them was designed, fitted together, and even tested in a virtual world first. This whole digital-first way of thinking is the secret sauce behind the speed and incredible precision of modern engineering.
So where does a journey like that even start? Well, it's not with some super complex software. It starts with something much more human, a thought, an idea, maybe even a quick sketch on a napkin. Let's dig into how that initial spark gets turned into a real structured plan.
And this right here, this is where the magic starts. It's this constant loop of ideas, sketches, and different layouts. This is the messy, creative part of the process, you know? It's where engineers get to just wrestle with the basic concept, long before they have to worry about every last nut and bolt.
Now, this whole beginning phase actually has a name, conceptual engineering. And what's so important to get is that this isn't just about drawing pretty pictures. It's the disciplined process of taking a marketing request, like, hey, we need a phone that's faster and lighter, and turning that into hard engineering rules and specs that a team can actually design to.
And the tools you need at this stage are pretty unique. An engineer here needs software that's super easy to use for quick sketches, that can pull in data from old designs, and maybe even run simple simulations of how parts might move. It's all about getting ideas down fast, not getting bogged down in tiny details. So let's see how these concepts start to take shape.
Okay, once that initial blueprint is locked in, it's time to actually give it some form. And that's where we enter the world of computer-aided design, or CAD. Think of it like a set of digital superpowers that let an engineer literally sculpt their ideas into existence.
The absolute foundation of all modern CAD is something called solid modeling. And honestly, the easiest way to think about it is like playing with digital Legos. You're creating parts that have real volume, real mass, they're solid, not just a bunch of empty lines.
And this slide shows the huge leap in technology. On the left is the old way, wireframe models. They're just the edges. But look at it, it's confusing. Is that a solid cube or just an empty box? You can't tell. But on the right, with solid modeling, there's no doubt. It creates a complete, totally unambiguous digital twin of the part.
But, simple blocks can't create everything. So how do designers get those sleek, aerodynamic curves of a sports car, or the comfy, ergonomic grip of a power drill? For that, they need a whole different kind of digital clay. And that is exactly where surface modeling comes in. If solid modeling is building with blocks, surface modeling is like being a digital sculptor. It's what allows designers to create all those beautiful, complex, sometimes even organic-looking shapes that define modern product design.
This visual shows you exactly how it works. Designers can grab and manipulate this web of control points, literally pushing and pulling on the digital fabric to get the exact curve and shape they want. It's a perfect blend of art and science, pure aesthetics guided by incredibly precise math.
And these surfaces aren't just drawn by hand. They're generated with incredible precision, by sweeping a curve along a path, or blending two different shapes together, or even spinning a profile around an axis. Just about every curve on your phone or your car was born from a mathematical process just like this one.
Okay, so you've sculpted your digital masterpiece. It looks fantastic. But is it strong enough? Is it actually going to work in the real world? Well, the next step is to test it, without ever leaving the computer. Welcome to the digital proving ground.
These are the questions that used to require building really expensive, really time-consuming physical prototypes. You'd have to build the thing, break the thing, and then start all over again. But what if you could just break it virtually first?
This is done using an incredible technique called Finite Element Analysis, or FEA. What this software does is brilliant. It takes your complex digital part and basically shatters it into thousands, sometimes millions, of simple little pieces called elements. Then it runs simulations to see how every single one of those tiny pieces reacts to forces like heat or pressure. The process itself is super methodical. First, in what's called pre-processing, the engineers tell the computer everything it needs to know, what the part's made of, what forces are acting on it. Then the computer does all the heavy lifting, solving millions of equations. And finally, in post-processing, all that data gets turned into a visual map, showing engineers exactly where the weak spots are.
Now, behind those colorful stress maps is some seriously heavy math, like the equation you see here. But don't worry, you don't need to solve it. The crucial takeaway is what it does. It takes a whole mass of complex 3D stresses and boils them all down to a single number that helps an engineer predict if, and more importantly, where a material is going to fail. It's basically a digital crystal ball for designers.
So all of this digital sculpting and virtual testing, as you can imagine, it takes a ridiculous amount of computing power. Your average laptop would just give up. So what kind of machine is actually powering this design revolution?
You are looking at a Sun Ultra Workstation, an absolute beast of a machine from its time. This was not for sending emails or browsing the web. This was a purpose-built supercomputer that sat on a designer's desk, engineered from the ground up for the intense demands of CAD and simulation.
And this chart just shows you why these things were in a totally different league. We're talking about specialized memory that prevents tiny errors that could ruin a week-long simulation, and a way faster graphics system designed to handle huge 3D models without breaking a sweat. Every single part was chosen for one thing: raw engineering performance.
And this number right here says it all. 800%. That was the increase in graphics bandwidth they got from this new system. For a designer, that meant the difference between a laggy, stuttering nightmare and a smooth, real-time creative experience. It was a complete game changer for productivity.
So when you put it all together, the conceptual design, the digital modeling, the virtual testing, all running on these powerful machines, what you get is nothing less than a full-blown revolution in how we create, well, just about everything.
And the difference is just night and day. The old way involved painstakingly slow manual drafting and just endless cycles of building and breaking physical things. The new way? It's fast, it's digital, it's driven by data, and it lets teams all over the world work together on a single digital model, perfecting it before anything physical even exists.
And this really matters to all of us. This digital process means the products we use get to market faster and for less money. But way more importantly, it lets engineers test for safety and reliability in ways they never could before, which leads to better, safer products for everyone. And it enables the kinds of innovations we just take for granted today.
You know, this quote from our source material just nails it. It's not just about making things. It's about making them better, making them more efficiently, and having this complete godlike view of how they'll perform from the very first sketch to the final product.
So, from a simple idea to a fully simulated digital twin that can be tested, tweaked, and perfected in a virtual world, this process has fundamentally reshaped our reality. It really makes you wonder, doesn't it? With tools that are getting more and more powerful every single year, what impossible things are we going to build next?